All right, hi everybody. Today we are talking about parallelograms. Okay, so we're looking at section 6.2. A parallelogram is a quadrilateral whose opposite sides are parallel. So the definition of a parallelogram is a four-sided figure with opposite sides parallel. So remember, to write parallel, we use the arrow symbols, not to be confused with the congruent symbols, all right? This is congruent. This is parallel. So please make sure that you do remember the difference between those two things. All right. So my blue sides here, BC is across from AD. They are going to be parallel. AB is across from CD, and they are going to be parallel. All right. In order to write parallelogram, if you want to use the symbol, which is just to draw a little parallelogram, you are more than welcome to do so. We are going to talk about several quadrilaterals over the next few days. This is the only one with a symbol that you can use as a shortcut. None of the others have one, all right? But parallelogram, we can write the little symbol here, and it does mean parallelogram ABCD. Now, we're going to talk about several properties of a parallelogram, all right? The first one is that opposite sides are also congruent. So our definition is that opposite sides are parallel, and our first property is that opposite sides are also congruent. So these sides are going to be congruent, and these sides are going to be congruent. All right? Our next couple of properties is that opposite angles are also congruent. All right? So angle B is across from angle D. They are congruent. Angle A is across from angle C, and they are congruent. All right? Our third property of a parallelogram is that our consecutive angles, so our angles that are next to each other, are going to be supplementary. All right, so let's take a look at why this is. Okay, I know that these sides are parallel, so we're looking at this angle here and this angle here. Notice they are same side interior angles. Remember, our same sides are supplementary. So that is why angle A and B are going to add to 180, B and C will add to 180, C and D will add to 180, and A and D will add to 180. All right? So consecutive angles, the ones that are next to each other, they share a side, are going to add to 180 degrees. All right, our last parallelogram property that we're going to talk about today is that the diagonals bisect each other. So that means each diagonal is going to cut the other one in half. So this piece here is going to be congruent to this piece here, and this piece here is going to be congruent to this piece here. All right, so the pieces of each diagonal are going to be the same length. One thing that I do want to give you guys a heads up on if you were absent in class today is that there are a lot of things to know in this chapter, okay? A lot of pieces and parts, and a lot of things to memorize. So please make sure that we're going to do quadrilaterals for a day or two, or for parallelograms for a day or two. Then we're going to move into special types of parallelograms. Then we're going to move into different kinds of shapes. So it is important that you are trying to learn which properties go with which shapes as quickly as you can, because all we're going to keep doing is just adding properties and adding properties. So it's a lot of properties that can be very confusing if you are not kind of really paying attention and memorizing as you go. It will get all mixed up in your brain if you do not do that. All right, so let's take a look at how we're going to use some of these properties. All right, so if we look here, I want to find the length of segment RS and the value of X. All right, let's start with X. All right, so for X, notice that it is a degree, and I know that this angle here is 115 degrees. Okay, they are consecutive angles, so they are going to be supplementary. So if we look here, notice on the left-hand side of your notes, it says which parallelogram properties were used in that left column. This is where we are going to write this. So for X, we are going to use that consecutive angles are supplementary. Okay, so I'm going to say that X plus 115 degrees is going to equal 180. So we're going to subtract 115 from both sides and going to get that X is 65 degrees. All right. Then for y, if I look here, I know that these two sides have the y and they are across from each other. So for y, I'm going to use the property that my opposite sides are congruent. And again, you're going to write that kind of over in that left-hand box. All right, so for y, I'm going to set 2y minus 3 equal to y plus 2. Subtract y from both sides, we get y minus 3 over here equals 2. Add 3 to both sides, we get y is 5. But remember, I wanted the length of rs. So for rs, I'm going to do 2 times 5 minus 3. So rs is going to be 10 minus 3, which is 7. Okay, again, we did this in class today, so if you are confused at all, please make a note somewhere in here, so that way you can ask when I see you again. All right, let's take a look at the next one. All right, we are looking at angle B has an expression and angle D has an expression. Those angles are across from each other. So the property that we are going to use is that opposite angles are congruent. So I'm going to set 4y equal to y plus 87. I'm going to subtract y from both sides, and I'm going to get that 3y is equal to 87. And I'm going to divide both sides by 3 to get that y is equal to 29. Now, I want the measure of angle B, so I'm going to plug that in. So the measure of angle B is going to be y, which is 29, plus 87. So the measure of angle B is going to be 116 degrees. Okay, so again, opposite angles are congruent, so we set opposite angles equal to each other. Okay? Let's take a look at the next one. We were told that ABCD is a parallelogram. This whole diagonal is 32, and this whole diagonal is 30. Well, remember that in our parallelograms, again in that left-hand box, we're going to write that diagonals bisect each other. So if this whole thing here, I know that these pieces are going to be congruent. I know these pieces are going to be congruent. So if all of AC is 32, we're going to cut that in half to get each piece is 16. Okay? If DB is 30 inches, we're going to cut that in half to get each of those pieces is 15 inches. All right? So diagonals bisect each other. The entire diagonal gets cut in half for each piece. All right? Let's look at the next one. Okay? We want to find the length of segment AD and the measure of angle B. So X and Y first, and then we're going to plug them in. All right, so we want to, over here, write which properties we're going to use. We're going to start with X, because part A is going to be the length of segment AD. So for part A, I am going to use the fact that opposite sides are congruent. So I'm going to write down here, again, this is in that left-hand box, that opposite sides are congruent. So I'm going to set 7x equal to 5x plus 19. Subtract 5x from both sides. I'm going to get 2x equals 19. So x is going to be 9.5. If I was leaving this as it was and I just wanted x, I would probably want you to leave it as 19 over 2. Okay, but since we're going to actually plug it back in, I will let you do 9.5. All right, so for AD, it's going to be 7 times 9.5 because it is 7x. And this is going to give me 66.5. Okay? Then for part B, I want to find the measure of angle B. These two angles are the angle measures that I have things for. They are angles that are next to each other, so they are consecutive. So my property that I'm going to use, can't spell, consecutive, is that my consecutive angles are supplementary. So I'm going to take 10y minus, I wrote an X, 10y minus 1 plus 6y plus 5 is going to be equal to 180 degrees. So we are going to combine like terms to get 16y plus 4 equals 180. Okay, subtract 4 from both sides. We're going to get 16y equals 176. And when we divide by 16, we get that y is 11. Now, again, I want the measure of angle B, so I'm plugging this in, and I'm going to do 6 times 11 plus 5. 6 times 11 is 66, plus 5 is going to be 71 degrees. All right? So again, in this one we use that opposite sides are going to be the same length, and consecutive angles are supplementary. So these angles are next to each other. All right, let's look at everybody's favorite. It is a proof, okay? We are given that ABCD is a parallelogram. We are proving that AB is congruent to CD and AD is congruent to BC. So we're proving the property that opposite sides are congruent. So we cannot use the fact that opposite sides are congruent because that's what we're trying to prove. All right, so let's kind of look at this here for a second. So it's given that we have a parallelogram, so we know that those opposite sides are parallel. Remember, that's what those arrows represent, is parallel. Now, the next thing we're going to do is we're going to draw in this diagonal. Now, please be aware that I will never ask you to do this step on your own in a proof. It'll either already have been drawn in for you, or like this is, I will completely fill in that step and you don't have to worry about it. Okay, so what does it mean to be a parallelogram? If I'm told this is a parallelogram, that means that my opposite sides are parallel, which is what we have here. So this is the definition of a parallelogram. And again, you can actually write out the word or write the symbol either way. So I know now that my opposite sides are parallel. So let's look at this piece. It says angle ADB, so ADB, this angle right here, is congruent to angle CBD, which is this angle right here. Look at these lines are parallel. I've got a transversal. These two angles are congruent, okay? They're alternate interior angles. Same thing with my other set, ABD, which is this angle here, and CDB, which is this angle here. Okay, that's parallel from these guys, so the alternate interior angles from AB and DC. So this is my alternate interior angle theorem. So we're going to see a lot of chapter 3 kind of popping back into here because it is the same thing. All right, DB is congruent to DB. That is my reflexive property. So what did I just do? I've got these angles are congruent, I have these angles are congruent, and this side in between them. I know that my triangles are congruent by angle side angle. So I can say that triangle DAB is congruent to triangle BCD. Okay? By angle side angle. All right, now, how do I know that other sides are congruent? How do I know the other pieces are congruent? Well, since I have congruent triangles, I know all the other pieces are congruent by our CP/CTC. Again, that is corresponding parts of congruent triangles are congruent. So we're going to see some of this stuff come back as we are proving these theorems. Okay, I know that makes you absolutely thrilled. But I promise you again, we can get through it. You can do it. All right? let's look at our last example that we're going to talk through here. Okay. And we have, or actually, I lied. I want you to try this one on your own. All right. Go ahead and pause the video. Give it a shot. I do want you to make a note up here about what property you're using. Okay. Once you have made that note, go ahead and solve the problem, pause the video, and then come back. All right, so go ahead and check your work, and you should be using the fact that diagonals bisect each other in order to solve this problem. So we set over here for JG. JG is part of this diagonal, so we're looking at our W's. So we're setting 3W equal to W plus 8. And then for FH, we're setting 4Z minus 9 equal to 2Z. All right. So a couple of different ways to solve it. So go ahead and check your work. And then please check eCampus for tonight's homework. All right. I hope you have a fabulous day, and we will see you later on.